Okay, don't know if anyone's actually here yet, but take a minute here to just look through. Anyone's got prototypes, really, frame. Yeah, no one's really touched the CAD yet. Guys, gotta get on that. Um, yeah, so work on Storm Surge is ongoing. Um, so what we're gonna look at here is variable libraries. Well, hopefully there are people here. Oh, so if you want to really rename this, name train dimensions. So there's a feature script called feature script taskbar is variable libraries. I want to select a like Art Studio. Okay, I need to make a new part studio to be able to do that. Yeah, I can do variable library. Yeah, variables part one. Current documents. Oh, okay, so I can import those by doing that. Um, but oh, okay. That's how this works. So if I want to use a variable library that I defined in the first file, I'd go to use libraries and select Part Studio. If I want to create a library, I could have to create it here. So if I want to say like example variable, value 1806 inches, I can. So then when I want, say, I went and can I create another? Okay, you can have multiple libraries. So I created this one already. It's a little bit incorrect. If I want to make that like 27.75 and 31.25, frame length would just be like 5. Frame bumper height is 5.5. Wheel channel, which is like the outer edges. Yeah, I can define all those here in a variable library so that they can be referenced in multiple documents. Then if I go back to the frame, I'm going to delete this sketch because I want you guys to. But if I want to make a rectangle, say, my first sketch, and then actually opt out of this, use libraries, frame, other documents, storm surge, frame variable library, part studio 1. hold on. It doesn't like that for whatever reason. Jump back to frame. Use. Is not seeing. Oh, variables. There we go. Took it a minute to see it. Yeah. So if I go variables, part one, select, should be able to go back to the sketch, dimension it to right. This I need to import the variable library before I can use it in the sketch. Ah, see, I can make this like frame length, and it just pulls in that number. Mention this, make it hashtag frame width, and then hit checkbox on that. And if I want to, I can extrude by bumper height, and it's all here. And if I leave this document, say you make a whole bunch of geometry to define our frame based on those numbers, I can go into the frame variable library and say I want to change the dimensions of the frame. I can be like, oh, this is 7-inch high bumpers now. And we're a 25 by 25 robot. And leave. Go to the frame and measure this. It didn't update yet. Oh, okay, so you have to create a version before it pushes. But if I want to go to V2 and then import new changes, I imported the wrong Part Studio. There we go. This should now be 25 by 25 by 7. So yeah, variables, they're really handy. We should use them this year. Let me fix. I don't want to create a new one. I actually want to get rid of V2. Well, what I can do is I can restore to main. Create version V3. And then if I go back to frame, I can look at variable library. Re-import the frame variable library. And we're back to where we were. So yeah, that I'll leave this here because this is nothing close to resembling what our actual frame should look like, other than it's a cube that would represent it. As a square. But, you know, you guys can continue working on catting the frame. Someone needs to take ownership of that. Anyway, see. Anything else we wanted to talk about for Storm Surge? Probably not. I don't see much in the way of prototypes being made here. Granted, it's only been a day. So let's see about some computer vision. So, computer vision. We haven't had time to do that for the last few years. I hope we get a chance to do that this year. You know, again, depends on how fancy we're going to be. So, most years the goals have retroreflective tape on them, and if you take a camera, turn the brightness down, turn up the exposure, and put green LEDs around it, what you get is, instead of something that looks like, you know, this, which is what your human eye would see on the field, you see that. Because retroreflective tape reflects light basically back at the source. I mean, it's kind of like the safety tape that you'd wear if you're like jogging at night or something. Yeah, I mean, you can see the bright lights in the background, but if you've got, you know, a specific color of light that you're emitting, you can get it back to your camera. So, you know, this requires usually a camera, a coprocessor, um, knowledge about computer vision and programming, but you know, I know a bit about it, so we should be good there. Uh, what camera and coprocessor you choose makes a huge difference in ease of implementation, speed, and accuracy. Ease of implementation is a huge one because, uh, computer vision is usually pretty difficult for teams to accomplish. We've done it a few times in the past. I've also overcomplicated it a few times in the past. Um, ease of, certain cameras like don't play nice with like the libraries that set brightness and contrast, so you want a camera that actually works with that. LifeCam and C720 are decent for that. You want a camera with a decent frame rate so that the robot's not acting on old data. You know, also the coprocessor needs to be fast. Accuracy, if the camera is like super distorted, it's gonna be hard for the robot to target right, even if it can see that. Cameras we've used in the past, Microsoft LifeCam, it's fairly low resolution, fairly reasonable choice. C720 is more of the same. Logitech Brio, I tried doing this in 2020 and it may be too high resolution for any reasonable coprocessor to deal with. We had to step the resolution way back. But like it is capable of getting some really good data to your coprocessor if you have something to deal with that. Coprocessors we've tried on the driver station, which was great until they limited our bandwidth in about like 2016, 2017, somewhere in there. On the robot controller directly, very slow. The Serio is not good at vision processing. The Jetson, kind of fragile. NVIDIA Jetson is kind of fragile, adds a lot of weight complexity. We've used Raspberry Pis in the past. It's better than Rio, but it's also still kind of slow, still adds some weight. Because like the Jetson, the Raspberry Pi, and the Jetson Nano, like if you know that like extra like network switch on the robot that everyone was confused about, it's for so we can use one of these that we never got around to running. Um, and the Jetson Nano might be a good option, but we ran out of time. Also, like making anything run fast on the Jetson Nano required a lot of my time to like compile WPI-lib on it. If you don't know what I'm saying here, just don't worry about it. Keegan's right. We'll get there, but just use the Limelight. Like, I would love to have some fancy Jetson Nano Logitech Brio vision system, but I don't think we have enough student or mentor buy-in to have me spending several weekends up there tuning it. So yeah, we probably just use a Limelight in the future. But also would require us to be able to afford a Limelight. They're not cheap. Processing frame rate is important. Bigger the input frame resolution, the slower the processing. It's kind of the problem we're having with the Brio is, the Brio can do 4K, but we don't have anything that can process it. Can be offset by higher performance computers. Like if we could get something faster than a Jetson Nano on the robot, the Logitech Brio starts looking really good. Slower processing means the data is more out of date by the time it gets to the robot. More of the same is, you want it running fast. Detail can be important. 2020, basically our grand scheme was we were gonna look at the left and the rightmost pixel in the contour. We'll get there. But basically, more pixels means we could maybe extrapolate the skew of the goal and try to aim for the middle better. We might not get there tonight, but there are some there are some instances where if you could deal with slower input data to get better data, or if you just have a good enough coprocessor to deal with it, more data would be nice. Being able to actually aim for threes when you're, off to the side would be a really nice feature of your robot. It would be really cool. We just didn't have time to do it. Most other teams just use the Limelight. We probably should too. And, if we need something fancier, we've got the parts laying around for a fancier vision processing. But to be honest, fancier vision processing falls into the purview of it's so complicated that it's really just my own pet project that I'm doing because I'm bored. But, it's got this nice web interface. It runs at like 90 frames per second. We should probably just fundraise and try to find a way to buy one of these things. Like, how much does it cost? $400. That was the other thing about why we tried using the Jetson and the Brio is that's like $150 webcam, and that's like an $80 coprocessor, and if it works, it should be better than the like Limelight. It's just we didn't have time to make it work. So, while the just use the Limelight is sure a convenient option, it's expensive and kind of a lazy answer. It's correct because we don't have time during the build season to mess with the Jetson, but maybe some summer we'll do a summer project where we mess with the Jetson and a swerve drive at the same time. So, how do you get data out of an image like this? There is this cool thing that WPI provides called Grip. You go to the link that I provided here and go to the tags here. You can download it and install it. I already have it installed here. So I'll kind of show you how to use it now. So you can go down here to add source once it opens up. You can add images, video file. You can directly connect a webcam or an IP cam or output to network tables. Why would you use network tables as an input? But whatever. You can, grab an image or a video file to experiment with. I have the goal image that we talked about here imported. So how this usually works is, you've got all sorts of like functions that you can use here. Um, how this usually works is get a there should be something here called a HSV threshold. Yep. Whoa. Not want to import this HSV threshold. Anything else want to work? Oh, that's not good. Try this again. What if I put this? There we go. Put the goal image here. I can click and drag and link to the input. I can show the output of the HSV threshold. I think green is somewhere around like here. But the best way I know of to figure out what color you should be targeting is just to open it up in like a picture editor. I'm using paint.net here just because it's what's installed on my system. And if I hit F8, I bring the color window open. So if I grab whatever color here, it's 153, 189. So see, we're cutting that off. But they're using like a 100. Also, this is taking forever to run. The other thing is I believe that's mapped differently. Yeah, it's 360 degrees, so like it probably actually is about where I said it was. Drag the sliders around. That's taking over a second. It's saturation is 100. Right? Yeah, okay. This is taking forever to run. Let me. I think the images do anything. Maybe also be running slowly because I'm streaming, but also just maybe that grip is running really slowly for no good reason. Yeah, because it's like barely using any of my processor. Hold on. Like, why is that so? not be could not be working as well as it is, or as poorly as it is. Shouldn't be detecting like most of this. What if I just like set it to one color, like it? Maybe the output's not updating. I think the output's just not updating. Yeah, the new version of Grip is busted. All right, I'm gonna go download an old version that actually works. This is what I get for not testing this before the stream. Let me go back to a stable version. Yeah, don't use 1.6 yet. Try 1.5.2. I think it's broken because they're trying to add like CUDA stuff to the new grip, which would be great because then it would just work on Jetson fairly easily. Or so I think. I don't know. They really need to make a Jetson version of grip. Because then we would just use our Jetson that we already have. Yeah, sure. Images. HSV threshold. I can show that. Oh, look, it's not running super slowly, and it's also just, you know. So yeah, do you see how this could actually be useful to tune things? Because I could just edit the values until it's like, oh, yep, we can just see the goal. So even if we used the Jetson or something and had to like custom write it, we'd probably get our values from Grip. So then what you do is once you have your HSV threshold, you do find contours wherever the feature detection. Find contours. The output goes into here, and so it detects a contour there, and that is like in programming you just get like a list of points is basically what a contour is. So you can do stuff on that. You can filter it. So like if I go and intentionally make this a little messier, what we can do is make like a minimum width of like 20, validity 100 ratio. So I was making changes that did things. I just forgot to turn it. Min width, max width, solidity. Huh, that's funny. Actually, turning the solidity down got rid of the extra contours. But so you can see how you can like use this to like test your vision pipeline. Like HSV threshold, find contours, filter contours. For retroreflective tape, that's usually all you need. there are other things where you can do color detection to like detect a ball, but it ends up being some permutation of this. And then you need to use the information, these points, to figure out where the goal is. So let's jump back to the PowerPoint for that. So what can you do with contours? You can get information from them. There's a link to a video for a more advanced implementation and for some functions that we'd actually use if we were doing vision processing. But for now, you need to know some information about your camera. So you need to go like look up your camera's horizontal field of view. Horizontal field of view is like, from like how far side to side your camera can see in degrees. Vertical view is just how far up and down it can see. So like, in degrees. Horizontal mounting skew, vertical mounting skew, both of those are just like how far off center your camera is on the robot. Like, and sometimes you can intentionally like work with the field of view and horizontal field of view to like make it work better. Don't worry about that. If we actually get to implementing vision targeting on the robot, I'll walk you through it. Resolution of your camera. So like 1080p is like 1920 wide by 1080 tall. If you know what a pixel is, like it's those little squares. We need to know that information about the camera to get information out of it. So, if you're looking at pixels, the pixel grid starts at 0, being the top left. So, like on the stream that you're watching or this capture slide, 0 is up here, like in the very corner. And then it goes X positive to the right and Y positive going down. You can, don't worry about the exact math here, but you can get, knowing your FOV and like how it's mounted on the robot, you can get horizontal angle to target from the camera fairly easily. Like that is the main takeaway I want from you guys to know here is you can get horizontal and vertical angle to the target fairly easily, knowing that information. If we ever get hands-on with it, we'll learn more then. How this is useful is once you have a horizontal angle to target, you can just do a simple PID loop to like center the move the drivetrain to look at a target. We'll do PID loops in a later lesson, like probably next week. Cheesy drive helper, cheesiest drive. Maybe when we get into actual code. I don't know if you guys will know what any of that is right now. If you know more information about the target, you can do more. It's usually a case of like algebra. Like the more known information and constants you can put in place of variables, the more you can just kind of hack the vision targeting and get, very detailed information out of very simple vision targeting. That's what we were trying to do in 2020. Latency is a problem. We have ways to mitigate this. I want you guys to think about ways to mitigate it. I'm not even going to go over that. That's way too complicated for you guys. So, the main takeaway I want you guys to know is that vision targeting exists and we can take advantage of it. I know how to take advantage of it. If we buy a Limelight, or even if we use the Jetson, we can. It is an option that is open to us. So if you want to put a camera on, your Storm Surge robot, that's probably a good idea. Probably put one of these for now.